Pseudocode and Flowcharts. We can use pseudocode to explain each step of an algorithm, using simple English and mathematical expressions. Flowcharts can also be used to show the same steps in a graphical manner. A flowchart graphically represents an algorithm sequence of steps, focusing on the process rather than the data flow. Both flowcharts and pseudocode are used to help programmers visualize and implement algorithms in any programming language. Various symbols are used to build flowcharts. The oval symbol is used to indicate the start and the end of the flowchart. The rectangle symbol is used to indicate a process, such as arithmetic or logical functions. The parallelogram symbol is used to indicate input or output. The diamond symbol is used to indicate a decision, resulting in a yes or no answer. Arrows are then used to link symbols together, showing the flow of the flowchart, and thus the algorithm. We can represent an algorithm using both pseudocode and flowcharts. Let's have a look at some simple examples. Here, on the left-hand side we see some simple pseudocode that checks whether a number A is smaller than another number B. If yes, A is incremented. Finally, the values of A and B are displayed. The flowchart on the right represents the same algorithm, just in a graphical manner. The first symbol is a diamond, which represents a decision, in this case is A less than B. If yes, then the next rectangle symbol, representing a process is executed. In this case the mathematical function of incrementing A is performed. If the result of the decision is no, then this process is skipped. Finally, no matter the outcome of the decision, is A smaller than B, the final parallelogram symbol, representing an output is executed, displaying the value of A and B. The second pseudocode snippet again checks whether A is smaller than B. However, this time if it is, A is incremented, otherwise, that is if A is equal or greater than B, A is decremented. The corresponding flowchart on the right shows the same diamond symbol, representing the decision if A is smaller than B. If yes, the rectangular process symbol, increment A, is executed, else if no, the other rectangular process symbol, decrement A, is executed. The next example shows how we can represent an iteration, or loop, using pseudocode and a flowchart. In the pseudocode on the left, a variable count is created with a value of 1. Then this variable is displayed and incremented a number of times, until count is equal to 10. The flowchart represents the algorithm by first using a rectangular symbol to assign a value of 1 to count. It then uses a parallelogram symbol to represent outputting the value of count. Count is then incremented within a rectangular symbol. Finally, a diamond symbol is used to represent the condition that is required for the iteration to stop executing. In fact, if count is less than 10, the previous two symbols are executed again, displaying count and incrementing it. Once count reaches 10 and the result of the decision is finally yes, the loop is exited and the algorithm ends. The first algorithm here represents a loop that does not end. We call this an infinite loop and it is undesirable in programming. However, in this case, it is important that blood continues to be pumped in and out of the heart. The flowchart only has two rectangular process symbols representing pumping blood in and out of the heart. It then loops back and repeats this forever. This is a problem, as a flowchart should always have a start and an end. The second example shows how this is possible by including a decision after the processes to be repeated are executed. In this example, the program will continue to search for a record until it is found. Once found, the algorithm will stop. Notice how the pseudocode does the same process but in a slightly different way from the flowchart. Here the algorithm continues to look for the record, while it is not found. Note, the exclamation mark and equal symbols represent when something is not equal. The flowchart on the other hand asks the question, is the record found, and if it isn't it continues to search for it. The difference can be seen if the record is already found before executing the algorithm. In the pseudocode no search will be performed. In the flowchart, the search will always execute at least once, no matter if the record is found or not at the beginning. The next example checks whether the temperature is above 25 degrees. It does this by reading the temperature. This is an input and in the flowchart it is represented using a parallelogram symbol. Both the pseudocode and the flowchart then check if the temperature is greater than 25 degrees. The pseudocode uses an if-else statement, while the flowchart uses a diamond symbol. Depending on the temperature value the algorithm outputs a sad or happy face. The pseudocode uses the if clause to output a happy face when the temperature is in fact above 25 degrees. The flowchart uses the yes arrow for this purpose. The pseudocode then uses the else clause to represent when the temperature is not above 25 degrees, while the flowchart uses the no arrow for this purpose, both outputting a sad face in this case. The last example is slightly more complicated, but if looked at step by step, it is easy to understand how the algorithm is working, especially when both pseudocode and a flowchart are available. Note here we are assuming that a list of different integer numbers exist, and we would like to find the smallest number in the list. First two variables are created, minimum and current number. And the first number on the list is assigned to minimum, while the second number on the list is assigned to current number. The flowchart uses two rectangular symbols to represent these processes. Next the algorithm checks whether current number, in this case the second number on the list, is smaller than minimum, which is the first number on the list. The flowchart uses a diamond symbol for this decision. If this results in a true, or yes in the case of the flowchart, the value of current number is assigned to minimum. If it is false, meaning that minimum is in fact smaller than the current number, nothing happens. This is done within a rectangular process symbol in the case of the flowchart. Current number is then assigned the next number on the list and a check is made to see if we have reached the end of the list. If more numbers remain on the list, the algorithm goes back to check whether the new current number is smaller than the current minimum value. Again a rectangular process symbol is used in the flowchart to represent the current number assignment, while a diamond symbol is used to represent whether the end of the list has been reached. This continues until we reach the end of the list and no more numbers are available to be compared. Once this happens the value found in the minimum variable will in fact be the smallest number in the list. Thank you for watching.